You're good to go.
All right. Well, good evening, everybody. Let me get my slides pulled up briefly here. And we'll dive in. All right. Is my slide deck coming through okay?
Yes, I can see it.
Okay. Excellent. All right. There we go. Well, let me just back up and introduce myself briefly. So my name is Sawyer Nyquist, which tonight I'm going to just introducing Spark as a big data tool and the details about Spark. But first, just let me say thank you. Just rush to say thank you. I'm excited to be here. I love talking about data. I love building new networks and connections in the industry. And so yeah, this is just a fun opportunity for me to spend an evening talking with you guys. So yeah, sorry, Nyquist, there's my email address. I run a small little side project called the Data Shop. And so this is one way you can reach out to me. There's an email address. I also love making friends on LinkedIn. So if you want to reach out on LinkedIn, send me a connection request. Enjoy. Made a lot of friends and connections and networking through there as well. And that's a fun place I'd like to hang out. This is the first time I've been a part of this user group. I'm looking forward to kind of joining in a part of this. Got a chance to share at a couple of other user groups over the last several months, and these are really fun spaces to be in. Let's see here. Let's see if I can get my slides to advance for us. All right, so just a little bit about me. I'm based in West Michigan, US, and so it's about, I think, about a 6-hour drive down the road from you in Toronto. I always say that Michigan is the state with the best summers, and I realize anybody outside of Michigan might have problems with that. I'm sure summers are wonderful in Toronto. I love Michigan summers, and so the last couple months here, when it's finally warm and we're out of winter, just love exploring water and the hiking trails, everything that there is to see and enjoy the outdoors. So I'm based in West Michigan. I've been a data platform consultant for several years, first at some Microsoft Gold partner firms, and then now at Microsoft for the last 2.5 years. And then I run a small boutique company called the Data Shop. And the main thing I do with the Data Shop is I write a daily newsletter called the Data Daily. And the Data Daily is a short daily email, Monday through Friday, goes out 5 days a week, about business. Well, let's see. The tagline I think I call it is helping data people with business and business people with data. That intersection between the business world, the data world, and those overlap, and really that section in between of like, how does data interact with business? How do business people think about data, and vice versa. I found that a really fun space to explore, both in my career, and I've had a really fun time writing about it. So if you're interested in a short email, you can jump on board there, thedatashop.co/daily, to just see what that's about. But that's a little background on me. Let me now pivot just to introduce our topic for tonight at a little more depth. So we're talking about Spark tonight, Apache Spark. And that it's a key player in the big data world. If you've been in the data world for any amount of time over the last several years, you've run across Spark. But there's also lots of different ways Spark shows up in the data world, and lots of different ways that it can show up in your data architecture, and ways you can leverage the way Spark is to be used. And so my goal with this session is to really spend some time first understanding like Spark at a core level. What is the tool and how does it work? And then start to explore those different, what I'm going to call flavors of Spark. So you can start to understand the different flavors, or what are the different use cases, maybe provides you with some tools for choosing a Spark option or a Spark runtime for your company, for your data platform, for specific use cases that you might be involved with. So that's kind of our North Star of where we're headed. We're thinking about Spark. We're going to lay the groundwork of what Spark is, and then what about it. So here we go. This is the detailed agenda. What is Spark? What do you do with Spark? How does Spark fit into data architectures? We'll look at a couple different patterns there. the flavors of Spark. And just a little spoiler, there are at least 4 flavors of Spark. Maybe it depends on exactly how you count. I'm going to roughly break them into 4 categories. And then final question is maybe how do you pick a Spark flavor for your company? And so this would be I'll call this like a 201 level presentation. If you're newer to Spark, then I hope there's still plenty of space for you to dive into this presentation, learn some stuff. If you're an expert at Spark, there's probably some time I'll leave at the end for corrections and debate about what I said or didn't say correctly. But hopefully this lands right in the middle ground where it's pretty interesting and helpful to most of you out there. All right, but let's dive in with just our first topic here. First bullet point, what is Spark? And as all intro topics need to begin, it starts with a Google search. So if you search for Apache Spark, you're going to land on spark.apache.org and the open source project page. And so here's what Spark is. It's a multi-language engine for executing data engineering, data science, and machine learning on a single node machines or clusters. And that's just the vanilla definition you get up front. And we're going to take that definition apart. But to place Spark in its kind of historical context, it's really the natural successor to MapReduce. And so if you've been in the data engineering game for a while, maybe 10 years or more, you probably spent some time working with MapReduce in the past. And Spark has pretty much supplanted MapReduce, primarily because it's in-memory data processing. And MapReduce was based off disk processing. So Spark becomes a dramatic improvement over the way MapReduce operated. So it's an in-memory data processing engine, and we're going to unpack that a bit more later on here. But let's take a look at that definition here. So that part underneath, what is Apache Spark? Here we go. We're going to break this down to 3 chunks. So what is Spark? What do you do with Spark here? And let's take apart the definition. Well, Spark is a multi-language engine for executing data engineering. And I want to highlight first off just the engine and data engineering. It's a data engineering engine. And so Spark is a compute software. It's a compute program. So it is great for reading and writing with files, working with files and events in a data lake, which is traditionally something that a lot of RDBMSs didn't do well, was reading and writing from data lakes. And so Spark has slowly slipped onto the scene as this really flexible compute engine for data engineering. It's great for things like streaming data processing and batch processing, building out code-based data pipelines and data movements. That's kind of one of the first core things I want you to think about when you think about Spark, is it's an engine for data engineering. The second part about Spark that I want to pull out of this definition is it's a multi-language data science and machine learning engine. So it's multi-language, polyglot, data science, and machine learning. So because Spark isn't just SQL, you also have R and Python and Scala and Java available to you. It expands beyond just maybe core data engineering tasks, as you get your advanced analytics, machine learning, and AI tasks that oftentimes land on Spark because of its multi-language support and its scalable nature, which we'll get to next. So first, it's a data engineering engine, and then it's a multi-language engine for data science and machine learning workloads. And so those advanced analytics type of workloads you'd be interested in, and those Python, Scala, R type of jobs. And then third, what do you do with Spark? Well, Spark is a highly scalable compute, and it's highly scalable because it can run it on a single machine, or you can run it on clusters of machines. Right, so it's a scalable architecture and because it's just a compute engine, it's fully separated from storage. And so we're going to get to that in a bit more later. But it's a scalable engine for data engineering, and then it's multi-language, which opens up the data science and the machine learning workbook to have fun playing in those spaces. So there's just a little bit of the intro around what Spark is, kind of what things you're going to do with Spark, and then we're going to put those pieces together a bit more and how they fit together in architectures. But to maybe provide a little more visual color for what we're looking at, here is just an architecture diagram of how Spark operates. And so we talked about it being highly scalable and distributed. Like a lot of parallel systems, you can add different nodes to your Spark clusters. And so here's an idea of how it operates. At the top, you have kind of the head node of the driver program. And this is the part that receives the task, the command from the user based on the code, and then it distributes it out to workers, and each of these individual worker nodes bring up data from the file system into cache and begin to operate on that task. And so maybe it's a count, it's a join, it's some sort of aggregations or more advanced processing. We get to distribute out the different tasks across worker nodes. And then it all reads from a Hadoop file system into something like ADLS Gen 2 or an S3 bucket or something like that. And so you can see that this can run on just a single node. You can have one node that's running each of the tasks. It'll take a little longer, especially depending on the size of your data. Or you can spread this out to as many worker nodes as is practical for you. And then you can distribute those tasks out quickly across a wide breadth of worker nodes and perform them much quicker. All of that kind of managed by the cluster manager. And so once the worker nodes finish up their task, they send the result to the cluster manager. And the cluster manager turns around and returns that result back to the user. And so if you're looking for some counts or some aggregations or some details around the workloads, the cluster manager sends that back to you once all the worker nodes finish their parts of the task and as it's distributed across them. So it's just a picture. Now, Spark is simple enough that you can install it on your local machine. I'll talk about that more in a minute. So it can be on your local machine, or more often in enterprise scenarios, it's installed across dozens of machines, perhaps, and on many different instances or many different clusters. So that was our intro in terms of what Spark is. What do you do with Spark? The details around data engineering, machine learning, and data science, as well as then the scalable architecture. But what does it have to do with our data architecture and our data architecture patterns? And I really want to introduce two key frameworks that Spark has enabled and really brought onto the scene for that have shaped a lot of how we think about data architecture over the last maybe 10 years, but more especially in the last 5 years, maybe the last 2 or 3 years, a lot, as it's really picked up steam. And there's two data architecture patterns, two key frameworks. And this first one is the separation of compute and storage. Right, so for the last few years in the data world, we've really made that key shift towards a separation of compute from storage. Right, so traditionally, compute and storage have been tightly coupled together in a SQL database. Right, your data lives where your compute lives and vice versa, and your database comes with X amount of storage and Y number of nodes, and then in those systems, the two generally scale together. And so when you hit a bottleneck on storage or you hit a bottleneck on your compute, you got to scale up both of them together. They generally went together, overall increasing your cost. But one of the things that's really special about having separate compute and storage, and one of the big advantages, is you can independently scale the two. And so now you're not forced to increase your storage with your compute. You can increase them separately, independently, decouple them. Another thing that it allows you to do is it allows you to bring your compute engine to the data. So as we talked about before, Spark is a compute engine. It's just that it doesn't have any disk storage. It just has in-memory storage. And so you bring the compute to wherever your data resides, whether that's in some sort of storage account, S3 bucket, ADLS container. You can bring your compute to your data. And there's some advantages to that show up. So one of the things that offers us is the ability to have, increased data storage control. And so I can choose what file type I'm going to use, what location, what geography I'm going to store my data in, what kind of redundancy protocols do I have, what kind of access controls and granular details around my data. I don't have to move it around. I don't have to load it into a different system. I can keep it in my storage account, and then my compute can exist entirely separate from that. So there's some good advantages to that. You also have some decreased cost. Okay, so storage cost, as you guys are probably well aware, is really, really cheap. It's just come down dramatically in the last several years, where storage cost is now a very low level consideration for a lot of things because it's so cheap. You can store gigs and terabytes of data at minimal cost in the cloud. And that's also a big advantage. Now I can store at the lake. The lake's really cheap to store data. It can be more expensive to store in different places. And then ultimately, these types of things enable a faster speed to analytics. And so moving data around, moving it from my source systems into my data lake and then into my RDBMS, that's expensive and it's time consuming. It takes a while to move data from place to place. It costs a lot, both in compute power as well as in human power, writing the code and managing pipelines to move data around. And so getting faster speed to analytics can be a major cost savings than as opposed to moving data around. So keeping it separate, compute and storage, allowing your compute, and specifically Spark being that flexible compute engine, to come to the data, and you bring your compute to your data. Data can stay put. You can have the decreased cost of cheap data storage, increased data control, data storage control, and then you overall increase your speed to analytics, because analytics can happen much faster when you're not moving data all the time back and forth. So there's kind of pattern number one is the separation of compute and storage that Spark really enables and empowers and brings onto the scene. And the next part is this thing called the data lakehouse. And everybody's heard of a data lakehouse. It's been one of the buzzwords over the last several years, introduced by Databricks a handful of years back. But I want to talk about how Spark enabled the data lakehouse and how it fits together. And so we've already covered kind of the flexible compute engine, but it's worth talking about kind of a second piece to that briefly. And so in a data lake, a folder of files doesn't make a database, right? So you have folders of files on your desktop computer, but that's not a database. And so until recently, all we really had was folders of files in our data lake. You would have, major file formats like CSVs or Parquets or Avro files, but those didn't allow you to do. They did a great job at storing your data, for sure. You could have great storage, lots of scalable storage, plenty of options, but you didn't have the key features that you need in many of your database, your core database functions. So a CSV file doesn't have ACID transactions or merges and upserts, rollbacks and restores. Neither do Parquet files, neither do Avro files. And so they were just files in a folder in your data lake. And all those complex operations that we always wanted and that we were accustomed to having in our databases, well, they just didn't work in a traditional data lake. That is until the advent of the open table format. And so here's kind of part one of part one is the flexible and scalable compute. Part two of building a data lakehouse is really having these open table formats. And so, CSV files doesn't work for a data lakehouse, but over the last few years, we've had the advent of these open table formats. Most popularly Delta, but also Hoodie and Iceberg being really key, really powerful technologies that now enable you to do atomic transactions, have consistent reads and writes on top of a data lake file system. And so now my files in a data lake can act like a database. And so this essentially allows us to have like table-like entities in our data lake, which really makes the evolution of the data lake into a data lakehouse. And so if we take our flexible, scalable Spark compute, we add in this open table formats, which Delta has become the big player, especially pushed by Microsoft and really backed by Microsoft there and Databricks. So Delta has become really one of the key things. Iceberg is also a huge player as well. But those two pieces put together, adding in some data warehouse modeling, and you still model your data in meaningful ways, model it like your data warehouse would be modeled. And that's what enables a data lakehouse. But data lakehouses could not exist and did not exist before you had a flexible and scalable compute engine, and before you had something like an open table format. Both those things, without either of those pieces, you would not have a data lakehouse. We would still be in data warehouse world. So that's kind of the second key pattern that has second key framework that's been enabled by Spark, as it's opened up and unlocked the data lakehouse framework and really the data lakehouse movement over the last few years that every every software vendor has really gotten on board because of the flexibility and power of it. All right, but that's our data architecture section. Now we're going to dip our toe into Spark and really into the flavors of Spark. And so we're going to walk through our flavors here at a high level, and then we're going to go into them in a bit more detail. I'm going to take just a second and get a drink of water. Just a dramatic pause for a moment there for everybody. All right, so the flavors of Spark. First off, you have an open source flavor. Spark is an open source project. It's available for free to download and install from Apache Spark or from the Apache Foundation. And so that's flavor number one, is an open source Apache Spark option. Flavor number two would be something like a managed Spark. And that's, in the Azure world, this is HD Insights, being a managed option. Flavor three is the one that everybody talks about right now. You end up lots of conversations about Databricks and Synapse Spark pools. These are the managed and optimized versions of Spark. And then the fourth one, the new player on the scene, Fabric. I was looking back, you guys have had some recent presentations on Fabric from some of my other colleagues at Microsoft. And Fabric is a big deal. It introduces for the first time a SaaS version of Spark. So a software as a solution, software as a service option for Spark. So those are the four main flavors of Spark, moving left to right from open source all the way to the SaaS version within Fabric. So those are our flavors. We're going to dive into them a bit more. But first, I need to take a quick sidebar because somebody out there is a Snowflake person and somebody out there is looking at these slides and wondering, what about Snowpark? And so Snowpark, if you haven't heard of Snowpark, Snowpark is Snowflake's, is marketed by Snowflake as an alternative to Spark. And so, the feud between Databricks and Snowflake, or maybe the playful banter and sometimes less, very not quite playful banter between Snowflake and Databricks, there's a bit of a rivalry now. And so Snowflake has developed Snowpark as an alternative and marketed as an alternative to Spark. So where does this fit in? How does Snowpark fit into our flavors of Spark? Well, first off, it's not actually Spark, although it has a very clever name. Nobody will deny that Snowflake has great marketing. So Snowpark is not actually a Spark runtime. It's very Spark-like, but it's not Spark. It's not built on the open source project. Rather, it is a translator on top of the Snowflake SQL engine, which is an excellent and first-class SQL engine. But it's not built on the open source project. It's rather built on top of the proprietary Snowflake SQL engine. And so that's one thing worth mentioning. And so it still supports SQL, Python, Java, Scala. So there's certainly parts of it that can work quite well. That can work similarly to maybe how you would do things in Spark, because you get the multi-language support. You still have a very fast runtime. And so for somebody who already has a Snowflake environment and is already using it for their data warehousing, Snowpark can be a really great extension of that and provide you the multi-language support and maybe some additional workload capabilities that you wouldn't have with just straight SQL. But it doesn't have near the maturity of a managed Spark runtime. I haven't used Snowpark directly, but just from my research in general, people talk about not having the same streaming capabilities, limited to no kind of library availabilities that you're used to with a lot of the longer and mature Spark runtimes that have been in the market for, a decade or more. So Snowpark's a new player in the scene. It's kind of Spark-like, not exactly Spark. Well, it isn't based on Spark. And it's kind of a little sidebar that sometimes gets introduced, maybe to confuse the issue, and definitely marketed as a Spark alternative. It's an option if you're a Snowflake customer already. Snowpark could be very useful, but it doesn't quite fit into our flavors of Spark. But we're going to jump in now and talk about the flavors. It's summer. I think about ice cream a lot in the summer. I love ice cream. And so we're going to talk about these flavors as ice cream flavors. I love ice cream, and I hope I make you hungry, and then maybe after this presentation, you go grab some ice cream from your freezer. Apache Spark, the first flavor, open sourced. I'm calling it the vanilla, the OG, classic, loved by all, vanilla Spark. All right, this is your first real option when you think about Spark, because you could always start right at the start, right at the beginning with the open source project. Now, some of the pros of diving into vanilla ice cream or the open source project is you get full Spark, all the features of the open source project, and no software cost. It's a free download. We could take 5 minutes right now, go install Spark. Might take you a little longer than 5 minutes. Install Spark on your local laptop, and you're off and running. No software costs. Obviously, you have the hardware cost if you need to have a system to run it on. But that's a great pro. But for many reasons, most companies don't use straight up open source projects. You know, it's kind of like a sign that says free puppies on the side of the road, and it's like, wow, like it's a free puppy. But everybody knows that adopting a puppy is not free. There's all sorts of care and feeding and vet bills that are required. And it's kind of the same with an open source project. It's free, but once you adopt that puppy, there's a lot of work to do to take care of it and to manage it. Thinking about, well, let's look at some of the cons. You have to manage the build, environments, versioning, clusters, all of those parts, patching, etc. when you get into taking care of an open source project. And so these are a lot of the reasons why most companies don't adopt the vanilla open source project. And if you're running, an open source project at your company, I'd love to hear kind of like why you guys chose maybe open source by itself. But most people opt for some sort of managed version. But if you're learning Spark, and maybe if you've never really heard about Spark or never thought serious about Spark until tonight, and you're curious about it, go out to Apache Spark, download it, and begin to learn about the design and the architecture of Spark and how to use some of the core features of it just on your local computer. It's free, easy to use. This is a great starting point. Dive into open source Spark. Especially if you're a little technical and enjoy reading technical documentation and using the command line and things like that. All right, but like I said, most people probably opt for some sort of managed option. And so a managed option of Spark might look like cookies and cream ice cream, where you get the original vanilla project plus some chocolate cookies involved, right? So who doesn't love cookies and cream ice cream? And so this would be something a managed Spark would be like in HD Insights. And, there's not a lot of people running HD Insights anymore, but there are some good advantages to it. And if you're in the AWS world, then EMR probably fits into this bucket where it's a managed cluster environment. But some of the pros of this, again, you get the full open source project. These managed Spark environments are built on the open source project, so they're all included. But you also get managed clusters, easier deployment, easier versioning, scaling. You get more granular controls over VM types and cluster managers and serialization. And so for the people who like to get their hands dirty, like to dive in and go under the covers to flip around knobs and switches, the managed options are really great. Or if you have some really nerdy and really specific or high needs type of workloads that require really custom configurations, a managed option can be awesome. Some of the things that make it great also are kind of drawbacks for some people. Is a lot more manual configuration required. It has a lot steeper learning curve, especially if we were to compare it to Synapse or Databricks, which are coming next. And you don't get performance optimizations. You get kind of the vanilla open source project with the managed elements, but otherwise you're getting normal Spark performance when it comes to how the data is processed and operates. You don't get a friendly UI or notebook environment. You kind of can manage your own notebook environments, but you don't get the Databricks environment or the Synapse environment that we'll talk about here in just a moment. That's flavor number 2 is a cookies and cream. Flavor number 3, and right now we'll group these together. We're going to separate them out in a minute. Flavor number three, though, because these really are similar in this way, is a managed and optimized version of Spark. And so this is a milkshake. You get all the great ice cream blended together to perfection, plus a whipped cream and cherry on top. And so this is the lots of pros to this option. Okay, so you're going to get all the core things from the previous ones. You get all open source Spark. Plus, you get a lot more user-friendly experience with the user interface. This is a PaaS solution, right? So the first one is much more like you have to you stand up all the infrastructure and then you install Spark on your infrastructure. This is a PaaS solution. The platform's there, the infrastructure's there. You still get a lot of configuration controls that are managed by the runtime themselves. And so that's great for a lot of companies or a lot of teams who don't want to have to control all the details of what Spark is. You can just pick a runtime and it's taken care of for you. You get some really easy integration with your core tools you're using, ADF and ADLS, dedicated pools, Git, etc. These things blend in extremely easily with those options. Easier cluster management, things like auto pause and scale and cluster pools, and there's even some like serverless options now that Databricks is presenting, and this just makes it really easy to think about managing cost as well as just when those clusters are running and how they're going to manage your workloads. This is one of those great things about kind of the managed and optimized. And then both Databricks and Synapse have put a lot of effort into not just running open source Spark well, but doing it with performance optimizations. And their teams have spent a lot of time building out things like caching and how the files are ordered and Z ordering and V ordering, things like that, to give you the fastest performance that isn't available in the open source project, but is available with these runtimes. And now cons, I mean, there's probably at least one. This is a more expensive option. You're going to pay more for more features, which shouldn't be a surprise to anybody. And I'd be interested to see if anybody here has any other cons that they might throw into the mix. But Databricks and Spark are going to be, or Databricks and Synapse Spark are going to be more costly options. There might be some other drawbacks too. If you think, if you've experienced this a little bit more, you might have run across some other things. But that's the main one that comes to mind right off the bat. All right, those are our first three flavors. And the last flavor of Spark, I had to think about a good illustration for this one. This is definitely the banana split. So this is the indulgent and iconic ice cream experience. Very feature rich, right? Okay. So for Fabric is, as I said, the first SaaS option for Spark. So the very first SaaS Spark experience, everything else has always been a PaaS experience, which means you're managing clusters and spinning them up and scaling them a lot more on your own. The SaaS environment takes away a lot of those controls, which makes it a very user-friendly experience. Easy setup, easy to use, minimal technical config. You can drop into Fabric and within a few minutes be running Spark. Less than that, like it takes you. You don't even have to provision a cluster. You just go once everything's on capacity already. And you've got really tight integration with OneLake and ADLS and Data Factory, and with shortcuts now, even AWS and soon to be GCP. And so Fabric as a SaaS option can offer some really great integration offerings. As I mentioned, really easy capacity management, no config, just assign a capacity to a workspace and off you go. You get similar, and I'll say the same performance optimization feature as Synapse Spark. It's the same runtime under the covers. It's just taken from a PaaS to a SaaS solution where more things are already baked in and not available to the user, but already managed for you. One additional thing that's kind of come in with Fabric is there's some cool VS Code integration. I was playing around with this a few weeks ago. Fabric's very new, so a lot of things are everything is still in public preview right now, but a lot of the tools are still maturing. But you get this cool VS integration where you can pull your notebooks from the Fabric workspace in the browser, and you can drop it down into VS Code and continue coding in VS Code, which is just a first-class coding experience. And then you can even have your your Fabric capacity running locally and connect to that and run your notebooks in VS Code on your Fabric capacity, having your great coding environment. That's a cool plus and a nice addition to kind of this addition on top of what you would get in Synapse or in Databricks. So some of the cons right now, cost, I suppose. Cost is still a bit of an unknown with Fabric. We have the pricing for Fabric. We know kind of what the capacities are, but we're not to the point of being able to compare production workloads well from Databricks or from Synapse Spark because, well, no one's running this in production yet, and they shouldn't be because it's still in public preview. But we don't know what cost is, but cost is probably going to be a little bit of a drawback because it's going to be more expensive than maybe some other options. Limited customization and config. So what would be a pro for some is also a con for others. Hey, you don't get to control under the covers. You don't get to pick your VM types. You don't get to really pick the sizing or the scaling and things like that of it. All that's kind of taken care of for you in this managed SaaS option. That can be a con for some people. Some people want to have more options there. All right, that's our fourth and final flavor of Spark. And now we're going to break it down at a bit more detail and compare them across. So if we walk through now these three options, I said we kind of combined Synapse, Spark, and Databricks together. Now we're going to break them apart and look at them kind of line by line and see what we're looking at. And we'll add in Fabric into the mix to help you figure out maybe which option you might want to choose. So going piece by piece, and this is Sawyer's opinion. This is not official for anybody out there, and this is an opinion based on some experience and based on my my read of the market and who's done what and what I'm hearing from friends and colleagues. But from a performance perspective, Databricks is still the leader in the marketplace. It's still the gold standard when it comes to a Spark runtime. So if you want the fastest performance right now, Databricks is probably going to be first place. Synapse, Spark, and Fabric are essentially the same runtimes in terms of their performance. So performance for workloads, Databricks comes in first. Features and configs, probably similarly. Databricks has been in the market the longest, has the most mature product. The other two are still, Fabric especially, still very new, quite buggy in places, lots of features that are still coming. It's a preview product. Synapse Spark similarly has features, has good config options, but it doesn't have the same quality or quantity that Databricks does. From an Azure integration standpoint, it's hard to beat first-party products like Synapse, Spark, and Fabric. Databricks does integrate well, but it's not quite the same ease of integration. So it gets a yellow up arrow. It's close, but it's not quite the same as working natively in Azure or in Fabric, which are just very tightly coupled right away. From a compliance perspective, companies that have stringent requirements might find it much easier just to stay all Azure, all Microsoft. And Databricks is introducing another vendor. It's sort of a first, third-party vendor of sorts. There's an official line there that I don't exactly know what it is, but it's very close to being Microsoft, but it is different than Microsoft. So maybe a compliance consideration that could come up for some people, depending on the type of industry that your company's in. Cost perspective, Synapse Spark tends to be a little bit cheaper than Databricks. Now you pay for what you get. It might be a little cheaper. You may not get some of the same performance or some of the same features and config. Databricks does tend to be a gold-plated premium option in the market. And Fabric's still a little bit unknown. As we mentioned before, I don't know. Fabric might cost a lot more, might be right in line, might be way cheaper. Really probably depends on how you leverage it, but those are yet to be determined until we end up with some good prod use cases. From the ease of use standpoint, Fabric just wins the day. If you have less technical developers on your team or people who are brand new to Spark and don't want to learn about cluster managers and cluster sizing configs and all those types of VM types, and they just want to write their code into a runtime and let it go, Fabric is just super easy. Super easy to dive into. Databricks and Synapse Spark can also be easy to manage, but not to the same level as a SaaS product. All right, and again, this is Sawyer's opinion. Do not blame any of these things that might be wrong on any of my employer or other people in the market. This is me. And next up, I promised you, and finally, I promised you the option or the ability to maybe get some tools for making a choice. So which to choose? What do you pick? How to pick a big data runtime like Spark between these options. And I'm leaving aside the open source project and HD Insights right now because those aren't the dominant choices that most people are faced with. Most people are faced with something like Databricks, Synapse, or Fabric. And at this point, it's been Databricks and Synapse. Fabric is very new and just coming out of the scene. But let's try it this way. Pick Databricks if you are already on Databricks, right? If you've already have any sort of meaningful footprint on Databricks, stay there. Don't leave. It really is a bit of a headache to try to switch runtimes. There's enough things that are different between Databricks and Synapse and Fabric that you're going to notice, and there's going to be a lot of growing pains. So stay on data. If you're already on Databricks, please pick Databricks and stay there. If you want or need the latest Spark version, then Databricks is going to still be your best bet for sure. Databricks gets the runtimes faster. They basically manage the project. Most of the contributors to the open source project work at Databricks. And so the latest Spark versions are landing on Databricks first. It takes a little longer before they make it to Synapse. If you want or need the most performance tuning options and config options, if you're running really complicated workloads, really large workloads, and you need the most performance, Databricks is your best bet. And if you're very interested in the most feature-rich product, so streaming is a big one that Databricks still excels at over these other tools. Logging and monitoring, the best performance options. That's why I would land on Databricks, and the ability to performance tune and configure your workloads on Databricks. Why would you pick Synapse? Well, pick Synapse if you've already got a meaningful footprint in Synapse. So if you already have a dedicated pool, or if you've already got pipelines, if you've already got, notebooks not notebooks, because you already have Power BI workspaces, and you're already using Synapse in other ways, then the single pane of glass that kind of the Synapse Studio presents is meaningful. It is useful, and it would be it can be clunky then to jump into a different workspace to do Databricks. Like I would stay in Synapse. I would keep writing your notebooks right next to where you're managing your pipelines and where you're doing your dedicated pool work and things like that. So I'd say if you're already in Synapse, stay put. I would keep going there and just use Synapse Spark. And if you have really stringent compliance requirements, first party versus third party vendor, if you just want to say Azure straight up and down, Synapse is going to be a great option. And if you're looking for the most cost-effective solution, your mileage may vary on this, I suppose. I've heard stories both directions on this. I think the majority of people find Synapse to be a slightly cheaper option, and so that could be a consideration if you're penny pinching or if you're cost conscious and you don't have high demand in terms of performance and need the best of the best. If Databricks is the gold standard, Synapse is a really great silver standard. And then why would you pick Fabric? You would pick Fabric if you already have a Power BI premium capacity. That would be a great reason to land on Fabric, because Power BI premium capacities essentially are Fabric capacities. And so in Fabric, you don't spin up clusters. You assign a capacity to a workspace, and then that's your compute for everything. And so if you already have a Power BI premium capacity, then Fabric is going to feel like a really natural transition. It's going to feel very smooth for you. It's just going to make a lot of sense, both conceptually for your users. They're just going to understand, they're just going to get it. And then also just like administratively and cost-wise, you're just familiar with how it operates. So Power BI premium capacity is a great reason just to step right into the Fabric world. If you're new to Spark and looking for the easiest user experience, please pick SaaS. SaaS is going to make your life much easier. When you feel comfortable with SaaS, then you can maybe step down the value chain and look for more technical, or if you like the technical weeds, step into some of these more complicated versions of Spark that allow you to have more configuration. And then pick Fabric if you want to leverage the other data components within Fabric. right? So if Fabric is your home for the future and you're looking at lake houses, warehouses, direct lake, one lake, those are going to be really interesting options and really interesting to build in that ecosystem. And that'd be a great reason to choose Fabric Spark as your flavor of Spark if you've got those pieces apart. Now, this might feel a little bit intuitive to just say, well, if you're already on Databricks, pick Databricks. If you're already on Synapse, and stay on Synapse. And the reality is that most of us aren't making a choice about a Spark runtime in a vacuum. Like most of us aren't like spinning up a brand new company with a brand new data platform. We don't have any existing ecosystem. Most of us aren't making that choice in the wild or in a vacuum by itself. Usually we already have some other footprint, some other thing in play that plays into our consideration, plays into our decision. And so if for some reason you are in a greenfield experience and have the option to start something from scratch, maybe those first options there aren't very helpful. But maybe the second, third, fourth bullet points might be more helpful when you're coming to a decision point around what do I do? Which one should I pick? And if nothing else, spin up all three and start to get some play around with different options and see what they feel like. The user experience is meaningful and is helpful. What are your developers using? What do they like? And then also like what's your performance like across these tools and really what does your data need? Do you need really advanced performance or are you running, do you have just a few, maybe a couple hundred gigabytes of data and you're processing batch every few hours or maybe once a day? You may not need a high performance runtime like Databricks without really stringent requirements. So all right, again, those are my opinions, but hopefully those provide some options for which direction to land. And you know what? That's all I had. Really want to spend a little bit of time on Q&A if there's some space or questions available that I could help if anything interesting came up that we'd like to talk about more. I don't know if there's chat. I might just peek at the chat box to see if there's any questions came in there or yeah, I mean, come off of mute and feel free to let me know if there's any questions I could help you with.
I don't see anything in the chat as of yet, but I know you mentioned it because I'm newer to Spark. So what's the best way to sort of learn about it? You said just to go, I'll let you answer the question.
Sure. So I'd say it depends on how technical you are. So one, like if you like installing open source software and you like playing in documentation and looking in the command line and installing software, like you might have a lot of fun diving into Spark. If you're less of a deep technical user and want to just figure out how to use like a user interface, then Fabric offers free capacities right now. And so for 60 days, you can hop into Fabric and have free capacity. And you're like it's really the Power BI tenant that then gets converted into a Fabric capacity, and you can create a notebook and you can just start writing code in either SQL or Python or Scala or whatever language you want to play with, and then just hit go and start running cells and having fun that way. That'd be a really light introduction to Spark. If you're a reader and you really want to understand Spark, there's a couple of great books. One's just The Definitive Guide to Spark. It's an O'Reilly book and written by the creators of Spark. That's like if you want to dive into the documentation, not the documentation, but like descriptions of how it works and how it operates, the architecture, how you would tune Spark workloads, that kind of stuff is really fun. And then I tend to start learning a lot of things just on YouTube and just start watching videos of like intro to Spark and see what you find. Again, it's a mature tool in the marketplace. So there's a lot of content available, and you can see specifically what's Databricks like, what's Synapse Spark like, and probably find plenty of good content there to at least scratch an initial itch and see then where you go from there.
That's great. Thank you. There's also a question in the chat, so the person can come off mute if they'd like to ask the question.
Hi,
It's Eric.
my name's Eric. Yep. I just have a quick question. For Fabric, I've tried the product and everything. I have a question because it's a SaaS, right? So you don't have control on the cluster. Is the cluster running all the time and you're being billed for your usage, or is the provisioning of the cluster every time you have a job being done, and that's part of your billing.
Yeah, with Fabric, you are paying for like you pay for a capacity for a month.
Hmm.
I think they're they've rolled out. I think there might be hourly pricing as well as an option. I think the majority of people are
Yeah.
going to buy it for a month capacity, and then it's just on available, and you can use it as much as you want to. It will scale up and kind of do bursting. If you like have really
Hmm.
high workloads, it'll allow you to scale up beyond kind of your initial capacity. But otherwise, it's kind of like you pay for that month rate. And then it's not just Spark, it's also your Power BI workloads. It's also data warehousing workloads. All those things kind of run on the same capacity. So it's a shared capacity across several different compute or several different data resources, data warehousing, data lake houses, Power BI. They all use the Fabric capacity. So when you pay for a month, it gets used in a lot of different places. It's kind of a different framework than how we're used to thinking about billing stuff, because if you've used Synapse Spark, you're like pausing and starting clusters and you're paid by the hour. Same thing with Databricks. But having like a dedicated provisioned capacity that you use across several different data resources is a little bit of a framework shift. And if you're used to Power BI Premium, then it can feel a little more familiar. But otherwise, it's a little bit new and different.
Okay, so the cluster is running on the background all the time. I'm coming from a background from AWS, right, with Glue, for
Yeah.
example. So
Mhm.
Glue, every time you run a job, it will provision the cluster, and
Ah,
then so it's per job, right? So
yeah.
it's not running all the time. So you're being billed with the actual uh, time that it's actually provisioned. So it's I'm just wondering if it's the same for Fabric.
No, when you have a Fabric capacity configured for your workspace, your Fabric, like your Spark session will start in 2 or 3 seconds. So I mean, like that's what it takes to spin up a
All
session,
right,
basically. The cluster's already running.
so it's
And then
already
each
running then.
each subsequent run, like it's like milliseconds to like connect a new session or connect a new notebook into that session. It's very fast. If you're used to 2 or 3 or 4 minute kind of spin up times,
Yep.
Fabric is going to feel like lightning compared to that.
Thank you.
And we just have one more question in the chat. It says how to experiment with Synapse.
A good question. And probably my first question back is, well, there's so many parts to Synapse. So Synapse Spark is what I've been talking about. But to be clear, like Synapse includes pipelines, which are just like Data Factory pipelines. It has data warehousing and a dedicated data warehouse engine. It has a serverless SQL engine, which is like Spark, only it's just straight SQL. But you can read and write files from a data lake really well with the serverless. Um, and then there actually is the Spark, which is notebooks, and then you get the multi-language support. That one's a little tougher just to experiment with, unless you have someone in your enterprise who will spin you up kind of a test or demo workspace. Um, uh, but yeah, so if you're able to, if you have a dev subscription or something like that, and you can have the option to spin up one of those, I would grab there's some great tutorials on Microsoft's website. Um, Download some data, open source data available, and easy, like, hey, I can read these files from the lake, I can write them back, I can write some SQL in this cell of my notebook, I can write some Python in the next cell. There's some fun tutorials to work through around. I think they use the NYC taxi cab data a lot. And then you can also even just use um, like worldwide importers or some of those like really standard Microsoft data sets as well.
Okay, well, thank you so much. There's
Mhm.
no further questions in the chat, and we thank everybody for joining us. And thank you, Sawyer, for an awesome presentation. Definitely want some ice cream now, but also as a beginner in Synapse and sorry, in Spark, that was a great analogy to use just to kind of describe it. So really appreciate you coming to present this. It was great, and we'll make sure that we get your contact information out there so that we can subscribe to your newsletter and connect with you if there's any further questions. So thank you so
Let's
much,
do
and
it.
thank you to everyone for joining. Have a good
Yeah.
night.
Thanks so much for having me. Really appreciate it.